Today's episode is brought to you by Skillshare. Hi, welcome to another episode of Cold Fusion. What do LASIK surgeries and GPS have in common? How is cloud computing connected to invisible braces? Did you know that scratch-resistant lenses were related to dustbusters? Actually, all of these things have NASA to credit for their existence. Yes, from the scratch-resistant lenses in your glasses to LASIK surgery that rids you of those very glasses. All are products of technologies developed by the National Aeronautics and Space Administration, or NASA as we call it. Contrary to popular belief that NASA is all about sending rovers to other planets and getting beautiful pictures, in reality, the space agency is a part of our daily lives and we don't even realize it. Still, the primary job of NASA is the exploration of the universe. A lot of you have probably seen the recent images of the Mars rover landing. Getting the craft to land on Mars was hard, but it's exponentially more difficult to send humans into space, and getting them back is even more difficult. Radiation, an absence of oxygen and water, escaping the Earth's gravity, and re-entering the Earth's atmosphere are all factors that make space travel extremely perilous. Now, imagine the scale of a disaster if an accident takes place in the void of space. Human lives will be lost in the vast emptiness forever. This almost happened half a century ago, in April of 1970, on Apollo 13. What followed though is a marvelous story of human grit, undeterred resolve, on-the-spot innovation, and unshakable perseverance. A true story that is comparable to any edge-of-your-seat sci-fi thriller.
You are watching Cold Fusion TV.
In the early 1960s, when the Soviets seemed to be winning the space race by first sending a dog and later a man by the name of Yuri Gagarin to space, the then US President, John F. Kennedy, challenged America to the ultimate goal, to put a man on the moon by the end of the decade. The dream was fulfilled when Neil Armstrong stepped on the moon on July 20th, 1969 for the Apollo 11 mission. Earlier, the Apollo 7, 8, 9 and 10 missions had been sent to the moon, but none of them involved a human landing on the lunar surface. With Apollo 13, NASA wanted to land astronauts in the Fra Mauro area of the moon. This is a geologically tougher landing site and is supposed to have been formed by an asteroid impact. For the Apollo 13 mission, the mission setup of the craft was in three parts. The cone-shaped command module, where the three men would be for most of the trip. The spider-like lunar module that would carry two of the three astronauts to the moon. And lastly, the service module. It was a large cylindrical craft with the main engines and oxygen tanks. During the mission, the service module would orbit the moon and rejoin with a jettisoned capsule that blasted off from the lunar module after the moonwalk was complete. This all had to be perfectly timed, a feat done by two onboard guidance computers, one in the orbiting command module and the other in the lunar module. Like the previous two Apollo missions, the crew consisted of three men. Mission Commander James Lovell, father of four and highly experienced. Command Module Pilot John Swigert, a last-minute step-in for another astronaut who had been exposed to the measles. And lastly, Lunar Module Pilot Fred Hayes, a rookie who left his wife and three kids on Earth. For a mission being so interesting, no one showed much interest when Apollo 13 took flight at 2:37 p.m. Eastern Standard Time on April 11, 1970. In 3.5 days, the trio would be walking on the moon. Perhaps by now, the last two Apollo missions made a walk on the moon seem more like a walk in the park. Even the live telecast of the crew flying through space all the way to the moon wasn't broadcast by major networks. But little did anyone know that within 10 minutes of the completion of the broadcast, something would happen that would pique the interest of the entire world. But for now, things were going well. While travelling at about 40,000 kilometers per hour, the crew would perform an 180-degree turn to dock the lunar module and leave the spent main rocket behind. They were now on their way to the moon. Everything was going smoothly. Quote, "We're bored to tears down here," said Joe, the capsule communicator, at 46 hours and 43 minutes. But unbeknownst to the crew, just a few meters below where they sat, there were some cracked wires next to a highly flammable oxygen tank. At 55 hours and 46 minutes, the crew finished the TV broadcast, in which the rookie Fred Hayes pulled a few practical jokes on his crew. His favourite was to push the repressurization valve, which produces a large banging noise. They were now 322,000 kilometers away from Earth, 4/5 of the way to the moon. At around this time, Jack turned on the fans to stir oxygen tanks 1 and 2 in the service module. Unfortunately for all on board, the cracked wires were now exposed. Tank number 2 exploded with a bang. They all looked at each other, thinking Fred Hayes was playing another prank. But this time, Fred was just as stunned as the other two. At this moment, the master alarm light and an electrical power failure warning was triggered. "Houston, we have a problem here." These were the famous words that Mission Commander James Lovell reported to Mission Control. Meanwhile, down on Earth, Mission Control couldn't believe what they were seeing. The warning lights indicated the loss of 2 of 3 fuel cells. They were the spacecraft's primary source of electricity. They realized that one oxygen tank was completely empty and the oxygen in the second tank was depleting. The engineers at Mission Control were scrambling to figure out what was wrong. There couldn't possibly be this many failures at once, or the crew would be dead.
It's as you fall back upon your simulation training and you start working the problem, and you work it the best you can. I was thinking that it was solvable, and then I was coming to the conclusion that I couldn't solve it. And that wasn't a good feeling.
But to the dismay of the engineers monitoring on Earth, the catastrophic failures were confirmed within a few minutes, and quite horrifyingly so. When James Lovell happened to glance out the left window, he could see a gas leaking. It was the oxygen from the second and the only remaining tank. At this moment, the crew knew that they were in big trouble. Amazingly, they didn't panic, as they knew that that would solve nothing.
We never panicked, and people often ask me why we never panicked, and the fact is we could have bounced off the walls for about 10 minutes, and when we finished we'd be back where we started from.
As the crew watched their precious oxygen leak out, they realized that they would lose all oxygen and soon, subsequently, their last fuel cell. They were now without electricity, light, and water 200,000 miles away from Earth, and still traveling rapidly in the wrong direction. Landing on the moon was out of the question now. The first thing they had to do was correct their trajectory. The explosion had shifted them off course, and if they didn't correct, they would still swing around the moon, but upon their return, they would miss the Earth completely. As the disaster unfolded, the news media began picking up the story.
From ABC News, Space Headquarters.
There has been an emergency in the flight of Apollo 13.
Some kind of explosion occurred in the spacecraft's main engine. The explosion affected the spacecraft's main power system supplied by fuel cells. And that means that their oxygen supply is in jeopardy and their water supply is officially termed critical.
The whole Earth was now watching, including the families of those in space.
I thought to myself, something's wrong. You know, my dad's never coming back. I'm never going to see my dad again. And, you know, he's basically, you know, I basically felt at that point that he was dead.
With no propulsion possible from the damaged service module, at 1 hour and 29 seconds after the explosion, the decision was made from the monitoring engineers on the ground that the crew should use the lunar module as a lifeboat. It wasn't going to be easy though. How would the oxygen supply be maintained? What would happen when power runs out? Was there enough food on the lunar module? What about water? How was the crew going to navigate back to Earth? All systems in the command module, except the critical ones, had to be shut down in order to conserve power. This would drop the temperature inside the craft to below freezing, and they didn't know if the guidance instruments could take that cold temperature.
The guidance system is like your eyes and your foot on the throttle and your hands on the steering wheel. It's the information that gives you the ability to, if you will, steer from one point to another. And so the question was, would the instruments be able to take the cold temperature?
With only 15 minutes of power and oxygen left in the damaged service module, they all made their way to the lunar module. Thankfully in all of this, there was one bright spot. Surplus oxygen in the lunar module, but only for a while. It wasn't an ideal situation, but it was going to have to do.
LM was a flimsy-looking, spidery-type vehicle. The crew compartment had
no amenities whatsoever. It didn't even have seats. The skin of the crew compartment was about 12 thousandths of an inch thick aluminum. That would be like 3 layers of Reynolds wrap put together. You could easily, if you were careless, put your boot or your foot right through that wall.
Yes, that's right. If someone moved their foot the wrong way, it could puncture the craft and their oxygen could escape, and they'd all die. Meanwhile, on the ground, the manufacturers of the lunar module were hard at work calculating how long it could support the life of 3 people instead of 2, as it had originally been designed. They calculated 2 days, but how long would it take for them to get home? Nobody knew yet. So the main question still remained: how do you bring the 3 men back home? They had 2 options. The crew could use the main engine to try and get back to Earth as quickly as possible, but run the risk of engine failure. Or they could take an extra 1 to 2 days to use the moon's gravity and fling them back towards Earth. They decided to go for the second option. They were going to go around the moon. This involved using the lunar module's rocket, which was never designed for this purpose, but even less so with the command module still attached. The center of gravity was now completely off, so the controls no longer corresponded to the inputs given. If you tried to turn left, it would pitch up, or if you tried pitching down, it would go to the right. It was like flying a fighter jet, but with all the control labels switched. They had no choice but to try. A 35-second rocket burn was carried out to speed up the craft, but the calculations made back on Earth said that they would run out of power and water before coming home. They needed more speed. But how were they going to figure out how to get up to speed? The onboard computer was very primitive. For context, this was a year before Intel had invented the CPU microprocessor. The Apollo computer could only store a few thousand numbers in RAM, and its power was orders of magnitude less than even a basic Nokia phone from decades ago. Because of this reason, all the calculations had to be done on the ground, and the instructions radioed back about when to fire the rocket, at exactly what power level, and for how long. The crew had to copy the instructions precisely before they lost radio contact when they travelled behind the moon. The calculations suggested that a burn of 5 minutes would cut 24 hours off the travel time, but it might not have been enough.
After the first hour or so, as we began to gather the data, and we saw those data points, heading down, it became obvious that within, an hour or so that we weren't going to make it at that rate.
The biggest power consumer on the lunar module is the guidance system. Merritt feels it's essential to turn it off, but Lunny and Krantz feel just as strongly it has to stay up and running so the crew can position the ship.
Glenn, if we don't get this thing powered down, we're not going to make it. And, of course, Glenn was receptive and said, well, let's see your data. Once you looked at the data and the data was coming in, it was obvious we weren't going to make it.
They decided to leave the guidance computer on for now, and then turn everything off and float to Earth in below freezing temperatures for 3 days. To conserve water, the crew had to cut down their intake to about 1/5 of normal. Worse, they were requested to not eject urine into space so they wouldn't disturb the flight's trajectory. This meant that the crew had to store their waste in bags and practically stop drinking water. They became dehydrated, cold, sleep-deprived, and Fred Hayes developed a bladder infection and then a fever. The other 2 crew members would wrap their bodies around him to keep him warm. They were miserable. By now, the entire world was following the updates of Apollo 13.
If I may be serious for one moment and ask the entire audience for a moment of prayer for the crewmen of the Apollo 13. We'll hold silence for a moment, please.
Countries offered help, and people across the globe prayed. The world watched as a dangerous adventure unfolded, an adventure that wouldn't be paralleled by any other in years to come. But even so, there were even more problems. The 3 men were creating excess carbon dioxide that needed to be expelled or they would suffocate. The lunar module was running out of carbon dioxide filters, but the command module had plenty of spares. The only issue was that the openings of the 2 filters were not compatible, so everyone had to get creative.
The problem was that we had these square canisters, and in the lunar module, the receptacle in which you put the CO2 filters was round, because the lunar module used round canisters or filters instead of square ones. So our problem was, how do we connect this square canister to a system that will only accept round filters?
With at least 2 more days of the journey still left, the challenge, however, was that Mission Control could only build prototypes, and the actual method had to be built by the crew as per the instructions from the ground. Even just describing the contraption was hard. Thankfully, the crew managed to do so using plastic bags, cardboard, and duct tape. Even after solving the problems of power, water, food, and excess carbon dioxide, the biggest challenge still remained: getting back to Earth. The touchdown was planned for the Pacific, but the craft could land in an unspecified range of hundreds of miles. Re-entry itself was a gamble.
Coming home from the moon, you had to come in and hit the atmosphere in a re-entry corridor that was only 2 degrees wide, a pie-shaped wedge. Not any less than 5.5 degrees, not any greater than 7.5 degrees. You had to come down that 2-degree wedge. If you came in too shallow, you'd skip out, like skipping a stone on water. If you came in too steep, well, that sudden deceleration would make you a fiery meteor over the sky for a few brief seconds.
Because they were coming in too shallow and the guidance computer was still powered off, the crew needed to course correct by hand. They had to line up the Earth in the center of their window and hope for the best.
I know that when that engine goes on, that I'll never be able to keep the Earth in the window by myself, because these are what we call 3 attitude controllers, in pitch and roll and yaw. I said, you take your attitude controller and keep the Earth from going back and forth too much. I'll take my attitude controller and keep the Earth from going up and down too much. He said, fine. And then over on the side, I had a couple buttons. One said start and one said stop. These were buttons that directly connected the battery to the descent engine. The one and only time they were ever used in the Apollo program. At the proper time, Jack said start. I hit the start button. The engine went on. 14 seconds later, Jack said stop. I hit the stop button. And in between that time, we juggled the Earth, up and down and sideways. And then, of course, we waited.
The last challenge was to move back to the frozen command module and power up its controls before the final flight to Earth. This required the creation of new methods. These methods would usually take months to be created, but they were devised in 3 straight days by flight controllers under the guidance of Flight Director Gene Kranz. The team on the ground were doing some of the most consequential engineering under a lot of pressure. Every calculation had to be just right. With 9 hours to go before re-entry, they were travelling at 32,000 kilometers an hour or 20,000 miles per hour. The crew wrote the instructions on whatever scrap pieces of paper that they could find on board. This takes over 2 hours.
We knew early in the game that the powered down levels would approach survival of the crew and the survival of the system. The systems would get so cold that we were worried that possibly the batteries might freeze. The propellant in the command and service module lines would freeze. There was a good chance we would get the combined spacecraft home, but when we brought up the command and service module, it would be non-functional. It was the end of the road.
But to everyone's relief, as the crew threw the switches to power up the command module, everything booted up. The components had withstood the cold temperatures far beyond their design limits. The crew jettisoned the service module. As the service module drifted away, for the first time, they could see the true extent of the disaster. The whole side had been blown off in the explosion. But now there was another risk. There was a possibility that their heat shield could have been affected by the explosion. If it was damaged in any way, it was likely that they would burn up in the atmosphere. But the crew couldn't think about that right now, as they had to jettison their lunar module lifeboat. It was time for re-entry. The flight finally entered the Earth's atmosphere. A communications blackout was supposed to last for 3 minutes as they turned into a glowing orb in the sky. When the blackout didn't end after that, everybody monitoring on Earth became extremely anxious. It was looking like the crew had perished upon re-entry. Then suddenly, the words "OK Joe" were heard.
Roger that.
After they crossed through the atmosphere, the crew deployed their parachutes successfully. They had done it. A huge sigh of relief could be felt by all.
3, 2, 1, 0. Roger that. 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 3
Finally, they splashed down in the Pacific Ocean on April 17th after 142 hours, 54 minutes, and 41 seconds of a perilous journey. All 3 flight members got home safe, and 1 million prayers from around the globe had been answered. The Apollo 13 Accident Review Board investigated the disaster and later identified the reason being a short circuit. It was discovered that when fuel tank number 1 was modified to be fitted in the Apollo 13 spaceflight, the voltage to the heaters in the oxygen tanks were raised from 28 volts to 65 volts DC. Unfortunately, the thermostatic switches on the heaters weren't modified to suit the change. The final test on the launch pad damaged the Teflon insulation on the tank, leading to the risk of a short circuit, which in turn caused the explosion. The command module is now kept in the Kansas Cosmosphere and Space Center in Kansas, while the lunar module is believed to have burned up in the Earth's atmosphere. The 3 crew members didn't get a chance to land on the moon again, but mission commander James Lovell became the first person to travel to the moon twice. Even though Apollo 13 couldn't complete its mission of landing on the moon, it's called a successful failure. A successful failure because NASA managed to bring the entire crew safely back to Earth on a damaged spacecraft. The mission gave several lessons to the space agency in terms of engineering and spacecraft design. This ensured future successes of Apollo missions. The story of Apollo 13 showcases the best of engineering and thinking on one's feet. Bringing 3 men back home from 200,000 miles out in space is a story for all time. If you do enjoy this channel, then I'm sure you enjoy learning, and a great way to do that is Skillshare. Skillshare is an online learning community with thousands of inspiring classes. It's a place where you can learn new skills or develop existing interests. I'm currently enjoying the course, Productivity for Creatives, Build a System that Brings Out Your Best, by Thomas Frank. One thing that stuck out to me was the importance of having a professional mindset in creative work. This simply means putting systems in place to get the work done. In the course, Thomas references an interesting quote by the author, James Clear. Quote, "You do not rise to the level of your goals, you fall to the level of your systems." So whether it's launching men into outer space or doing creative work at home, yeah, it turns out that systems are important. Whether you're looking to fend off boredom or focus on self-care through creativity or just want to get more work done, Skillshare has you covered. The first 1,000 people to use the link in my description will get a free trial of Skillshare Premium membership, and after that, it's only around $10 a month. So thank you so much for watching, and also thanks for all the comments from my podcast appearance that I linked in the bottom of the last episode. They all really mean a lot. So next on the channel, I have some interesting stuff coming up, such as the origins of Bitcoin, and also what all the fuss is between the Australian government and big tech. So stay tuned for that. Anyways, my name is Dagogo, and you've been watching Cold Fusion. Feel free to follow me on Instagram and Twitter, and I'll see you again soon for the next episode. Cheers guys. Have a good one.
Cold Fusion. It's new thinking.